Hello, everyone, and welcome. My name is Sierra King, and I am the Director of Admissions at the Data Incubator, and we are a fellowship, scholarship, and placement company. We've promised you an excellent info session that will be led by one of our instructors, Ana, who will introduce herself very soon. But Ana will be walking you through the process of visualizing geospatial data in Python and sharing some tips and tricks. And I believe there'll be a few links that will be posted in the chat so you can follow along with Ana's discussion as well. But to start things off, I wanted to give you a quick overview of our programs and everything that we offer at the Data Incubator, and then I will hand off to Ana, who will lead us through our discussion, and then we'll leave some time at the end for questions. A few housekeeping items. Today's session is scheduled to last 1 hour, and that does include a Q&A, so after you see Ana's presentation, you will have time to ask questions. All participants are muted to enable speakers to answer as many questions as possible, but you will have that opportunity to ask questions, and we ask that you submit them in the Q&A box. We do have a moderator here, Raven, who will be answering questions during the presentation if they're more about the program or general questions, and then we will have the Q&A open to the specific discussions questions later on. The chat box will also be used for general announcements and resources, so please avoid using the chat box to ask questions for the panelists because we want to make sure that we don't miss your question during the presentation today. And then if you have a question that we either don't get to during the session or you don't feel comfortable asking in a group session, you're also welcome to email us at admissions@thedataincubator.com, and we will be happy to get back to you there or schedule a call with an enrollment counselor. And we'll also drop that email address in the chat box as well. And lastly, the question we get asked most frequently is the session recorded? And yes, it is. It will be sent out to all of our scheduled attendees today. It usually takes about 72 hours to process. If you want to watch it sooner than that, it is also will be linked on our YouTube channel as well. So with that, I will pass to Ana to introduce herself.
Thank you so much, Sierra. So my name is Ana. As Sierra said, I am one of the data science instructors at Pragmatic, the Data Incubator. My background is in physics. So after finishing my PhD in physics and doing some postdoctoral research, I sort of meandered into data science from there. So I have many, many years of experience developing scientific and commercial data processing software, building simulations, building machine learning models, and things like that. At Pragmatic, I teach everything from our basic Python courses to the most advanced courses we offer. And today I have a demo of some visualizations prepared for you. Should I jump right in there? Can I do? Yeah.
Yeah, a couple slides we'll go over first, and then we'll
okay, sorry.
So again, we wanted to give you a quick overview of our programs before we launch into our demo. And if you're new to the Data Incubator, you may be wondering, what do we do here? Well, the Data Incubator focuses on training people to become data scientists and data engineers. And we get asked quite often, why is that important? And well, it's really because data professionals have the ability to work with the latest tools on unstructured and structured data to drive business value. And that is a big need in the world right now. We work with companies in a variety of industries, ranging from tech to retail, healthcare, and many more. Really, every company has data and wants to use the data to drive value for them. So there are a lot of other data-focused programs out there, and I'm sure you're wondering what we do at the Data Incubator that's just a little bit different than those other ones. Well, what we found when you look at training, there are really two types, one being fast-paced and efficient, and two being slower and focusing on understanding and completion rates. University is one example where you receive a more detailed understanding, but with a lot more time invested. And then on-the-job training is usually very quick and efficient, but maybe you're not fully understanding what you're doing. So what we've done at the Data Incubator is we've taken all of these aspects and combined them together to find a great middle ground for training. Our program is fast-paced. You walk out of the program knowing a lot about data science and data engineering, but most importantly, the real-world business applications, and with a deeper understanding as you get from university. All of our instructors are PhD and master's holders, and many of them have completed this program themselves, so they know how to provide that in-depth training that you're looking for. And for our fall cohort, we're offering our 3 data-focused programs. We'll be offering our successful full-time data science fellowship program and a more flexible version of that, our part-time data science program. And then we are also continuing to offer our data engineering program as well. And I want to take some time to review the similarities and offerings from all 3 of our programs. All of our programs are very intense. They are built around hands-on focused data curriculums, and we offer both full-time and part-time programs for our data science, and both are packed with a lot of information and tools. Each week focuses on a different data tool or approach. And in addition to our lectures, we have our students participate in hands-on practice because we really believe in fostering an interactive learning environment. And so in each program, students will work on mini projects that focus on the tool that you're studying. Additionally, our programs are very collaborative. We want students to not only work with their colleagues and instructors, but also have the opportunity to network and connect with our hiring partners. We also have a team of career coaches that help you succeed in your data-focused careers. You'll not only learn how to present your best self by attending our career search workshops, but you'll also have the opportunity to work with a #1 resume writing company to get you a polished resume and cover letter that is focused on data science or data engineering. And lastly, all of our programs are interactive. Every student in our program are provided a Jupyter server for the duration of the course, so students can follow along and lecture and see and edit raw code that's being run. And students will also receive immediate feedback via our interactive grader. Just quickly going through our program curriculum. So for our full-time data science program, it lasts for 8 weeks with classes held daily. You can expect to spend about 40 hours per week outside of class working on assignments. And then here is an overview of our full-time curriculum broken down by weeks. And if you would like to see a more detailed curriculum or syllabus, again, please email us at admissions@thedataincubator.com. We'll be happy to send that to you as well. And in our part-time program, it lasts for 20 weeks with classes held on Tuesdays and Thursdays from 7 p.m. to 9:30 p.m. Eastern. And you can expect to spend about 10 hours per week working outside of class, and office hours are available each week. You'll receive the same excellent curriculum and training as our full-time program, but at a slower pace. And these sessions are still live and instructor-led, so you're able to interact with your instructors and peers and ask questions. And then lastly, for our full-time data engineering program, similar to our data science program, classes last for 8 weeks and are held daily. You can expect to spend about 40 hours per week working on assignments, and then another overview of our program broken down by module. And again, if you have more questions about the data science or data engineering or the difference between the two, you're welcome to reach out to us at our admissions inbox there, and we'll be happy to schedule a call with an enrollment counselor. So that is just a little bit about TDI and our programs. I will now pass to Ana to lead us through our live data demo today, and then we'll be back on at the end to help answer any questions.
Thank you, Sierra. So let me go ahead and start sharing my screen. So you should all be seeing my screen now. I think you also, yes, I see it in chat. You have a link there to a binder link so that if you follow that, just give it a moment for Binder to start up the notebook, and you can follow along if you would like. So for today, I wanted to show you how we can create some cool visualizations that are going to be nice, and they're going to be interactive, and we will be using geospatial data for this. And the key actually will be that we'll be using what I think is a very cool library called Altair that will allow us to do all of that with not a ton of code. We will be using Python, of course. This is a Python library. It's called Altair. I have a link there if you followed the link to the notebook. So more on Altair later. I should say that in Python, sort of the number of tools you can use to produce visualizations is really large. There's so many libraries. You may have been using things like Matplotlib or Seaborn before, and then there's also Bokeh and so many other things that you can be using. And depending on what you're trying to do, different tools will be the right sort of tool for the job. But what I love about Altair, as you'll see in a moment, is kind of what you can achieve with quite a little effort that you'll see. So hopefully I'll convince you it's easy to use and produces awesome visualizations. I am going to be using for this demo a data set of wildfires in the US. So this is a data set that contains over 20 years of geo-referenced wildfires. So for every incident when a wildfire was detected, in this data set, we are going to have an entry there and have some information about it. As you'll see in a moment, we are focusing on larger wildfires, so only those larger than 100 acres across. So let's load in the data. I will be using, actually, let me just for a second, I see that I already ran this. So let me just do this so we start off clean. We're going to import pandas, of course. Our data is in a CSV file that we will load by, of course, calling the read CSV function from pandas, and that gives me a pandas data frame. This data frame has almost 50,000 entries. So we have almost 50,000 wildfires here with 11 different features or columns. So if we take a peek at this data, it looks something like this. So every row is a fire that was detected. We have information about the year when it was found, the day in that year. So that would be the 280th day of 2004. The time when it was discovered, the size in acres of the fire, latitude, longitude. So that's the geospatial component that we're going to include in our visualizations. The abbreviation of the state where the fire happened, the county, the class of the fire. So depending on the size of the fire, if it's larger than some amount of acres, it's classified as A. If it's larger than something, it's B, C, D, E. So this tells us basically the size of it. And then we also have the description that actually describes the class. So apparently G is for those fires that are greater than 5,000 acres, and F is for those that are in this range. And then we also have the state column. So that's going to be the data we will work with. And we will first actually need to clean up this data a little bit. You may notice that the year column looks a bit consistent just by looking at it. But if we also take a look at that column and look at all the unique values in that column, you see that occasionally we have something like 2004, or let's say 2008, but sometimes just 08 standing for 2008, or 1999 or 1999. So let's make sure that we have this data clean so that when we try to use this data in a visualization, we can do something with it. So what I'm going to do is I will create a function here. There's different ways you could do this. I'll just write a simple function that I will then apply on this column fire year that will clean this up. And essentially what I want to do is in this function is something like, I'll do this very simply. Entry is going to be whatever is the entry in my column. So it will be a string. These are strings. So I'm basically going to say if I already have something that has 4 digits in there, so if the length of this entry is already 4, I'm good. In that case, I don't need to change anything. I'm just going to make it into an integer. Yeah. But otherwise, in that case, what I'm going to return is I am going to take, then I know that it has 2 elements, the string does. So what I'm going to do is actually from date time, there is a function in there that is called strp time. And that is a function where I can pass in a string. I can specify in what format is the string. And that is, I have year. That's the kind of the command to tell Python. I'm dealing with a string that tells me the year. So this percentage sign, what y, means a year, but without the century. So just this. And what I want to do is this converts it into a date time. And when I just call year on that, that'll just give me the year. So now that I have this function, if we tested it, if I called this function on, let's use it on some string, let's say 2004. Well, it's just 2004. But if I call it on something that's 04, then this happens. It converts it into a date time and then just gives me the year. So that's exactly what we wanted. Awesome. Let's apply that function on this column. So on the column large fire year, I will now apply that function and apply on a pandas series, which is what this is, calls this function on every value. And whatever are these new kind of fixed corrected years, I assign that back to that same column. So after I do this, now wonderful, my year column looks dandy. We can get started. Okay, and now let's do some visualizations. Now that my data is clean, I have looked at it before. I know that all the other columns are ready to go as well. But otherwise, of course, we would want to make sure that all the data is ready for what we want to do. And let's do some basic Altair visualizations first. So this will not be interactive just yet, and it won't be as fancy as what we will conclude with. But let's start with basics, because Altair has a slightly different syntax than you may be used to from plotting libraries like, let's say, Matplotlib or Seaborn. So let's first, of course, import Altair. And let's start with a very, very basic plot. So essentially what I am going to do is just make some, let's say, some scatter plot where we are going to first just use California fires though. So let's first just restrict ourselves. Here we have all the possible states in here, but I am going to actually restrict myself only to those rows that have California in this column. So let me first create this data frame here. So from the entire data frame that's called large fires, I want in the column state AB to have California. So that's my condition. In pandas, it means I have to put it in square brackets and the name of the data frame in front. So what I just did there is I just filtered out only those rows that have California in the state abbreviation. Okay, so now that we have this data frame, let's do some plotting. So what I'm going to plot in Altair is I'll make a simple scatter plot first. Let's imagine that we're interested in how does the day of the year in which the fire was discovered depend on, or kind of what's the relation between the day of the year and the size of the fire, for example. Yeah. So if we want to make a scatter plot like that, that means on the x-axis, I want discovery day. And on the y-axis, I want, let's say, fire size. So the way I make a simple scatter plot in Altair is we will always use this chart object in Altair. So we imported Altair as ALT. So if I say ALT chart, that's the beginning. I'll always start with that. And in Altair, that means that in here, I need to pass basically my data source. So I'm going to use this data frame right here. I'll pass it in there. And then what I need to do on that is a couple more things. I need to tell my plot what kind of markers I'll use. Do I want scatter points, in which case I'll say mark point. Do I want a line plot? Then I would say mark line. And you'll see a couple other options later on. This is going to make a scatter plot. But I also have to tell it, what do I want to plot on the x-axis? What am I plotting on the y-axis? Which column information am I using maybe for color or for size of my points? So that comes in encode. That is Altair's way of telling it, what do I want on which axis? Now, I am actually going to go to a new line here, just so that this is going to be a little kind of nicer and easier to read. Yeah, oops. So I'll do this. You can obviously keep going in a single line, but I just find it kind of a little bit easier to read like this. And in encode, we have to tell it, so on the x-axis, what I want is, I want this column, discovery day. I'll just copy it from here so to not make typos of column names. And on the y-axis, I want fire size. Let's just do that for now. So if I do that, and if we look at this scatter, which is my scatter plot, I get an Altair plot. Yeah, nothing fancy so far. I can, of course, also in encode specify, okay, so on the x-axis, I have this column, on the y-axis, I have that column. I can also say, why don't we color according to what is in the column fire size class, for example. If I do that, then I'm going to have a different color for different classes. Something like that. So in here, we could now see in what time of the year there seem to be more larger fires and things like that. So this was just a simple Altair plot. Now, and this followed this very general scheme of you specify your data source, which you pass into chart. That again returns a chart on which you say, what kind of a plot do you want? That again is a chart on which you call the next method, which here encode tells us what are my visual cues, how am I using the axis and other things. And we can define interactivity, which we didn't do yet. Let's do that now. I have code here that's exactly the same as what you've seen up there above, except for this line actually. So let me maybe get rid of it for a second. So it's really the same as what we had above. We just added interactive at the end. That's it. And after I did that, I probably am missing that now. Yeah. So after I did that, now this plot is interactive, meaning I can drag things around. I can scroll in to zoom in, right? Didn't do anything here. So you see how Altair sort of is this very nice wrapper around some JavaScript that you would otherwise have to write yourself to have such nice interactive behavior in a browser. We're using a Jupyter notebook, so it's in a browser. And I didn't need to do any of that. Yeah, I've just written a little bit of Python code and I have this nice interactive plot that, by the way, is very easy to then embed if you are doing any web app or anything that requires a web-ready visualization. You just plug that in there. And all of this doesn't require anything other than saying this. That is if we only want to zoom in and zoom out. We're going to add more interactivity in a moment. Yep. So that's our very simple scatter plot for now. Let me add the part that I deleted that was already there. On top of, for example, specifying what's on the x-axis, what's on the y-axis, what's my color, I can add tooltip. Yeah, this is all in encode. And I can specify which columns from the data frame, I will be using when I hover. So let's run this. When I hover over a data point, in this case, you see tooltip says latitude, longitude, which means that when I hover over a data point, it tells me the latitude and longitude of that entry in the data. And here, of course, this can be just a single column name, or if there's more, you pass in a list of them like we did here. All right. Wonderful. So in this case, we did a scatter plot. Now let's create a histogram. So it will also be very similar to what we did before. So we'll be using that same data. And that means that I am going to pass into my chart. I'm going to pass in our data. We are still working with our California fires. And then what I will do is, instead of mark point, which we had before, we are going to mark bar. That just means that I am going to have bars because I'll be plotting a histogram and I want to make bars right now. And now for our encode, well, it's up to me, of course, to decide what kind of a histogram I want. Let's imagine that we want to make a histogram of different fire sizes across California. That means that on my x-axis, I want, let's do fire class size, for example. Let's use that for our x axis. And then on my y-axis, I want, for example, the count. So if you want to make a histogram, that's all you need, essentially. Yeah. So we could stop there. Yeah, and that's it. You can add, as you maybe, if you were kind of saw that I had a properties here. Properties is something that allows you to specify a title like I did here. It also allows me to specify the size of the plot. So if you were to follow this with, let's say properties, of course, again, I can have a title here. I can also say width of my plot, and I can say I want it to be wider, and then that's the size of it. Yeah. And of course, I can add the hover here, which means we would just here add the tooltip and everything you've seen before, whatever other columns I may want to add. Yeah. So that's now a histogram. Good. So we created a simple scatter plot and a simple histogram. We are going to soon start doing some geospatial plots. I do see that we are getting some questions in Q&A, and I think that maybe I'll leave those for later. When we actually go into Q&A at the end, I'll try to answer as many questions as possible. So before we do a geospatial plot, let's also look at maybe the number of California fires over the years. So what I mean by that is I am going to make an Altair chart where, again, my data is the California fires. And now I'm going to make mark line. Let's imagine I want a line plot. Yeah. And if I, in a line plot, also say point equals true, that creates a line plot where also the actual data points are also, it's kind of like a scatter plot on top of a line plot, as you'll see. I need my encode. So what I am going to do here is what I would like to encode. Let's imagine that on the x-axis, I would like to have my fire year column. And on the y-axis, now I want the count. So you may have noticed that this is Altair doing quite a bit of work for me. Yeah, same as here when I just said count. That means that it did some group by. It grouped by this column and it counted how many rows have a particular fire class. And here similarly, now it's telling me how many rows have a particular year in their fire year. In other words, how many fires do I have every year? And again, we could add interactivity here. We could add by saying interact. We could add our tooltip and things like this. All right. Maybe just one more thing I am going to mention here. You may notice that this is perfectly fine, but fire year itself is considered here to be a numeric column because we made it into an integer column. In our data, if you go and look at the data frame, it's an integer. So therefore, it just comes up with some integers here on the x-axis. Nothing necessarily wrong with that, but you can control in Altair whether certain columns are treated as numeric, which would stand for Q, or whether they're categorical, so basically nominative. And I can do that here if I do N like this. Now it's no longer a numeric. This is not, doesn't mean numeric. Q would be numeric. So this N stands for, it's basically treated like strings, if you will. So in that way, I have those values that were in my data also appear as ticks. This is just slightly stylistic in this example. I just want to mention that. So there's a lot of things you can customize, of course. Okay, so these were some simple scatter plots, a simple histogram or a bar plot, and a simple line plot together with the scatters, right? So if this is the part that I mentioned, if I get rid of this, then we have just the line plot where I don't have the points there as well. If you want them as well, you can add this. So let's move on to doing some actual geospatial plots. That's the part that always gets me excited. I don't know why. I love plots of maps. And I find Altair to be so easy to do this. So we are working with something that's in the US. So we will want a plot, usually when we create like plots of latitudes and longitudes and what happens where, we usually like to have the kind of the map of the area plotted behind it as well. And there's different ways of how you can do this. I'm going to do the simplest way of just importing from Vega data sets data. And on there, you have this particular URL that is the URL to the data that contains different types of essentially information about maps. And if you pick feature states, then you can load that into Altair's topo feature. And that gives me what we're going to call states. So let's plot states, whatever that is. Let me show you what it is. Let's plot it. So in Altair, the way I would plot this now is going to be just the background of the US states. And the way I can do that is I say Altair chart, that's always going to be the same. And now I'm going to plot states. That's the data I'm plugging in. And now what is going to be my mark, it's not going to be mark point, it's not going to be mark line, it's going to be mark geoshape. This is geoshape. That's telling Altair essentially that I have some geoshapes and how this should be plotted. And here I can specify different things. I can specify in what color each state in my case will be filled. I'm going to say light gray here. I can specify the color of the lines around the states. So that's going to be my stroke, which let's say it's going to be black, and so forth. You can kind of customize this in however you'd like. Now, what I also want to specify when it comes to geospatial plots is the projection. Yeah, so you may know that when you have some geospatial data, you do need to specify kind of how you're going to project the fact that the Earth is round, but our plots is going to be a flat two-dimensional surface. So you get to pick your projections, and the projection that we are going to do here, here you can play with different ones, but Albers USA is going to be the one that's going to look most like the kinds of maps you're used to seeing, as you'll see in a moment. So actually, we can just show what I'm talking about. This gives us just a map of the US with every state in light gray and the edges of each state in black. So now that we have this background, and here you can also specify, I guess, I think in the example that you may have if you're following along, we also specify the size of this particular plot. So I can say that if I want it to be a little bit bigger, let's make this something like that. Okay. Oh, did I? What? That's better. Yeah. So that's our background. We haven't plotted our data yet, but I have a plot of the US now. And now what I'm going to do is I can easily plot on top of that in Altair. I will make another chart that we're going to call points. So this will be another Altair chart. And then the way that I use this chart that we're seeing here that we called background, and on top of it, plot from my data, the chart, I just do this background plus that chart where I'm about to create is going to plot on top of the background. Now let's create this Altair chart. What I want to plot here is, remember our data that was the California fires. Yeah, let's imagine that I want to plot, of course, the location of every fire. So let's have the latitude and longitude be what I would like to plot. Yeah, and I am going to, of course, do that by saying I want an Altair chart, and the data is this data frame. So you know this by now, yeah. And then I have to specify what kind of a mark I'm using. Let's just make circles. Wherever I have a circle, wherever I have a fire, I'm going to make a circle there. Yeah. Now I do have to still specify my encoding. So in this particular example, I say encode. And now, because I am going to be essentially doing a geo encoded plot, I simply say longitude is my longitude column, of course, and latitude is my latitude column. Yeah, basically that. Now let's add tooltips and things like that in a moment. If we just do this, we should have our background of that we had before, and then every little circle here is a fire in California. There's too many to actually see individual circles. We'll fix that in a second when we are going to plot separately just fires for a given year. But for now, if I plot all of them across 20 years, they mostly overlap. But I guess I can get a little bit further in seeing what we're plotting there. If I, for example, add at least tooltip. Yeah, so if I added here, let's say latitude, longitude, whatever order we like, and maybe also fire size, for example, you get to pick which information you would like to be there when I hover over a fire. Yeah. All right. So this is our first sort of geospatial plot, but I would like to now add, first of all, a bit more interactivity, but also because in this particular example, right, we had these fires, we have so many that they're overlapping. So I want to instead create the same plot, but where only fires on a given year are plotted. And then can I have a slider where I'm going to be able to select what year I want to be looking at? Let's do that. So the first thing we're going to have to do if I'm doing that is basically we're going to have the same thing as we have here. So I am just going to copy this, if you don't mind, so that I don't have to retype because a lot of it is going to be similar. So I'm going to have my data set of my fires. We're doing circles, a latitude, longitude, and those are my tooltips. But on top of that, what I need to do is I've actually want a slider. Well, let's make a slider. I'm going to call it slider. The way that you create a slider in Altair is Alt and binding range. That will give me a slider. And I can specify what is the minimum value. In my case, I know that the data goes from 1992 and the maximum goes to, I think, 2015 or something like that. But of course, here I could just not necessarily hard code that in, but have instead the max of the particular column. And I can also specify the step size here. So I would like my slider to go in steps of 1 when I move it so that I go every year at a time. That's just the slider. Now I need essentially also some functionality, if you will, associated with it. And that is that what's called a selection in Altair, where I am going to have something like Alt and selection, and I will select single. That means that I get to pick 1 year. A single value will be selected. I give it some name. In our case, this is our fire year. Yeah, that's the column name. So let's give it that name here. And what I need to do is I will have to connect it to this slider. Yeah. So there's a couple of things I actually have to specify. So one is I do have to say which column that is, which I specify by field. So that is fire year, and that's the name of our column. And I also need to specify, so what is the bind? Where do I select this with? Well, you'll be selecting this with this slider. I put that there. And we can specify an initial value. So when the plot is created, at what value is the slider set? So let's say that fire year, when I start, I don't know, whatever value we want. Let's be at 2000, doesn't matter. Yeah, year 2000. Now that I have this is still all fine, but it's not connected to my chart in any way. And the way that I can do that is what I need to do is 2 things. I first have to add selection. That means that when I select something, slider, add selection, that means that when I am selecting something in the slider, I've connected that to the chart now. But what do I want it to do? When I select a given year on a slider, what would you like that to do on the actual plot? Well, I would like it to filter, yeah, and that to filter out just the data and that year, and that in Altair is called transform filter. So if I on top of that, actually, shouldn't be slider here. It should be this. So I should give this a name. So let's call it select year, for example. That's what I have to pass in here, not the slider, sorry. Yeah. So this connects to the slider via this, but this is what has to be passed in the add selection and in transform filter. So in that way, now I have kind of connected this plot to the slider, and I have told it, what do I want it to do with the year that is selected? Well, filter. Therefore, a lot is going to happen for me here under the hood. Yeah, well, we can run it and see. So all of the things that happen is that when I am at a certain year, at the start at 2000, because I said 2000 here. But then what that means is that at that selected year, that single selected year, what Altair does for me is it filters out from the data only those rows with that year, and then it plots that. So that means these are all fires in 2002. And if I move that slider, I get, well, whatever year I want to investigate. I hope you find this as cool as I do. I love Altair. I think it's just so little code, and this is so cool. And I didn't even use a lot of, I guess, customization. You can certainly pick your colors and all sorts of things that you may want to do. But even just so, I think it's kind of awesome. One thing I do want to show you as well is what we can do is, again, not just, for example, specify just longitude, and tooltip. I could specify color. Maybe I want different classes of fires colored differently. I will actually use the size of every point to be dependent on the fire, how big the fire was. So the way I can do that is I can, on top of latitude, longitude, and tooltip, I can say scale. And the way that I can specify which column I want to use, I just can say fire here. So fire size. This would alone work. So actually, what did I do? Oh, it's not called scales, it's called size. Sorry. Yeah. Now I could just do that. And you can see that here. Then therefore, that's a huge fire and that's a very small fire. And all of this works finely. You do want to be careful that as you change the year here, do you see how the scale changes? So a fire of this size, meaning the size of the circle, I mean, doesn't correspond to the same size of the fire as that same circle size on a different year. So if I want to kind of keep that steady so that I really can see, in case I have a big fire in some year, yeah, that corresponds to the same number of pixels, if you will, you can do that. It just requires a little bit more work here. I can't just specify the name here, but I have to say from Altair, we'll be using size. And the column that I want is fire size, just like that. That was basically the same as what we've done so far. But if I use this syntax, it allows me to also specify the scale that I want. So that just means what's the range of values I allow here. So if you, for example, here did that, so that's what's here essentially. What's the minimum and maximum is what I'm specifying here. So I can say my domain, and here I would basically go from what's the smallest fire in my data, what's the largest fire in my data. I'm just going to put some numbers in here, right? So let's say from 5,000 to 300,000. But you could tweak that, of course. And all I did this is fixed. So that means that now really a fire that's really big here means it's really big across all the years. Okay. I'm looking at the time. I'm almost out of time, but I just want to advertise this little last section that is in this notebook that you can access through the link that was shared. And that is, if we wanted to maybe color every state according to the number of fires there. That means that we have to go back to the original data frame that has fires from the entire US. We'll have to group by those two columns to obtain this basically data frame that tells me in this state, in this year, you have that many fires. And now that I have this, let's just plot it. The only thing I have to take care of is that the way that Altair will do this, as you'll see in a moment, is it has to essentially have an ID associated with every state so that it knows which one's Alabama. Every state has an ID, not just a name. So I have to bring the ID of every state into this column. You have a data set included that contains that information in the repo that contains this a notebook that was shared with you. So if I just merge this data with this, now I have all I need. Yeah, now I have the ID also there for every state. And now we basically are doing here the same slider as before, the same selection as before. Most of this is the same. The only difference is that here into alt chart, I'm plugging in this data frame, this one, and I'm saying mark geoshape. We already saw that before. And this is the key here. This is different. I am saying transform lookup. This is what tells Altair basically lookup from this ID. That's the chloropleth ID. And if we run this, you'll see that what I get is kind of what I advertised so that I have every state now colored with the amount of fires in a given year. Because I added this same slider from before, I just copied it here and I added it here as add selection and transform filter. No extra work there. Yeah. So if I now move this around, it's for different years, I have different amounts of fires. Okay, I'm looking at the time. I think I'm out of time, so I'll stop talking. There's a couple more suggestions here. You can go over to Altair if you want, especially to the gallery. There's tons of examples. And if you just click on something that you like, if you're like, oh, this looks like, I don't know, exactly like the plot I need, you click on it and it comes with code. So feel free to take that. Obviously, of course, feel free to take the code that I've shared with you here and have fun with it.
Thank you so much, Ana. So if you have questions that you'd like Ana to answer, please put them in the Q&A section. We are opening up questions in about 5 minutes, but we have a couple more information and resources for our program that we'd like to share. So I'm going to steal the screen from you, Ana, and go over a few more things before we open up our Q&A. So we get asked quite often if we ask scholarships for our programs, and the answer is yes, we do. We admit 2 types of students into our data science and data engineering programs. Fellows are offered a full tuition-free scholarship for our full-time program, and we offer a limited number of these scholarships to highly qualified candidates. Fellows are expected to leave any current employment to attend our programs and are expected to interview exclusively with our hiring partners. Scholars will pay tuition to participate in our program. They are not required to interview solely with our hiring partner network, but they can use those resources and can maintain their current employment. Scholars still have the same access to curriculum, resources, and tools as our fellow students. The only difference is that full tuition scholarship. And then just keep in mind when you're applying for the program, the full tuition scholarships are not offered for the part-time program. We're also really excited to announce for fall, we are offering 2 new scholarships for our data science and data engineering programs. We'll be offering our Equity and Diversity in Data Scholarship and also our Women of Excellence in STEM. And these scholarships aim to help remove barriers and provide opportunities for women, veterans, LGBTQ+, and students from racial and ethnic backgrounds that are traditionally underrepresented in technical roles. So if you apply for one of these scholarships, you'll receive $3,000 off your tuition for our data science or data engineering programs. A big component of our program that we really pride ourselves in addition to our technical training, is also helping our students not only grasp the data science concepts, but getting a job in that field. And that's really the challenge, not only learning the content, but being able to transition into a data science or engineering role. And that's where our program stands out, because we help you to do both. We see that 88% of our students are employed within 6 months of completing the program, and 97% of those students that go through our program are currently employed outside of academia. So where are our graduates now? Where are they working? What are they doing? Our graduates are working in 55 different industries, and some of the most common industries we see are computer software, internet, IT, financial services, and biotech. And then some of the typical roles we see are data scientist, data analyst, research scientist, software developer, product engineer, data engineer, and many more. And these titles and roles vary depending on the company and industry, but they are just some of the roles that we've placed in the past. And then here is a short list of some of our data science fellowship hiring partners, and many of these are also hiring for our data engineering program as well. And another question we get asked pretty frequently is, do we offer financial aid options? And the answer is yes, we do, and we offer assistance. So in addition to our scholarship, we have partnered with LEAF to provide an income sharing agreement. It's a great option for a lot of our students. You can participate in our program with just a deposit down, and you won't be required to make any payment until you've graduated and are working and earning more than $40,000 annually. We also provide traditional loans through Ascent, and Ascent offers 3 options, being deferred repayment, interest-only repayments, or immediate repayment. So depending on which option works for you, you'll be able to select one of those 3. And then lastly, for many of our programs, companies are willing to sponsor or pay for their employees to go through our program. It's a win-win. You get to learn great stuff in the evening and be able to apply it to your job during the day. So if this is something that you think your company would be interested in, or you would like to present to them, we do have a letter we can provide you that will help you lay out the program and all of the benefits of attending. So where are we right now in our admission cycle? Well, we run multiple cohorts a year, and our summer cohort is starting very soon towards the end of June, but the application for our fall cohorts is now open. So a couple important dates to keep in mind: the fall full-time cohort will run from September 19th to November 11th, and for part-time, September 19th through February 3rd. And we ask that you submit your application by July 1st for our early admissions deadline, and then you'll have 72 hours to complete the coding challenge from the time that you open it, and the challenge deadline will be July 4th. You can't complete the challenge unless you submit the application. So just in general, I recommend you complete the application and challenge sooner than later to avoid any technical issues. We're not able to reopen it after those deadlines. But that's for our early admissions. We do also offer a regular admissions after our early admissions cycle. And the difference is we evaluate candidates on a first come, first served basis. So if you want to have a better chance of getting a fellow spot or one of those scholarship offerings, or just knowing earlier that you've been accepted into the program to secure financing, I absolutely recommend applying for our early admissions application. And we also offer a priority enrollment package. So that includes access to a Python training course, early access to career services, and a one-on-one with a data science resume writer, as well as $2,000 off your tuition for direct payment. And if you're interested in applying, which I hope you are, you can go to the dataincubator.com/apply to submit your application. And then again, if you have questions about your specific situation, this presentation, or just going through our application process, please reach out to us at admissions@thedataincubator.com, and we would be happy to answer your questions. So at this point, I will open up our Q&A. I know we have a lot of questions in there for you, Ana, already, so we can just pull those up now. I think you might have answered them, some of them.
I've been trying to type to make sure I got to almost everything. There's one more that I was about to start typing with, and I think these two kind of connect with how you can bring in other geospatial information what I guess is already in Altair. So we were using states as the plot of states. Altair, of course, doesn't have everything in there. There could be some city map that you can still use that already comes in the Vega datasets that we used, but otherwise you should be able to basically have some JSON of the background, whatever map may be that you'd like, and you would essentially just plug it in there where we plugged in what I was calling states. It may require playing around with it a little bit. You have to make sure that the JSON is of the right form, but it's certainly very much doable. Another option, if you just want to focus in a single state, is just to basically in Altair focus on what latitude, longitude you plot. Here we plotted the entire US, but you could just change the limits on X and Y axis and hone in on a given state. So just like if you wanted to use exactly what we did. So it would take a little bit of tinkering around, but I encourage you to do so. There's also a lot of course, Stack Overflow posts and other places where you can find it to kind of make it fit your needs. I see a third question that so can you plot with just state data? Does that mean for just an individual state maybe? Yes, you can, like we did for just California. So if you wanted to have just California, you could isolate that from the data that's being plotted and just have California plotted, or zoom in on it, if you will. And state rather than latitude longitude data. Yes, that's kind of what we did in the last example, right? Where we didn't use latitude longitude, but it was every state had some value associated with it. In my case, it was the number of fires. So if every state has some value associated with it, you would do what was the last example that we did. Do you mind sharing the data set with us? Yes, everything is there. So let me maybe also post the binder link that you were given. Will happily, of course, work so it pulls that data. But let me also share the link to the repo itself. So the GitHub link, should I put that in Zoom chat? Does everybody see that? I just did that. Did that work? So hopefully that's where you can find the data as well. Can two different charts be interactive? I'm not sure what you have in mind, but I'm going to basically say you can do anything. So yes, but maybe if you mean that you have the background, that's one chart on top of another one, and they both have their own interactivity. In principle, I think you could have a tooltips that's on the background and tooltips on the one on front. And depending on what you hover on, I think that should work, if that's what you had in mind. Are all these visualization tools open source? Yes, they are. Separate two charts that interactively filter the data. Yes, you can have a slider or or some sort of other drop-down menu or something that filters the data. And if you just add it at the end of your code for a given chart, then that applies just to that chart. So yeah. Yeah, now I don't know where to look. Does it have animation capabilities? For example, you create a short clip running through the years on the slider. The last time I tried to do this, I saw that being as a sort of issue on Altair's repo, kind of one of the suggestions that they should add to the project. And so the last time I checked, I don't think you could do that just by simply with Altair, I mean, with just some Altair commands. There's always kind of a workaround, but I don't think that existed, but I may be wrong. Maybe it's been added since. Are there any other places? How do you decide on the projections for different maps? I would just look at it and see what you like most, right? There's different ways of how people have taken the map of the world and flattened it. We are all used to this particular view of the world that's actually quite distorted, right? Where the size of Africa and the size of all the continents is what we're used to seeing, but that's just a projection. So I would play around with it, just change what your projection is, and whatever you think kind of suits best what you're trying to achieve, you can use that one. There are some more standard ones, like the one we used here. That's a standard way of kind of how the US would look when it's flattened. I don't see anything else very useful. Just wanted to confirm that classes are daily as opposed to Pacific time. I think that's a question about Eastern versus West Coast versus East Coast times, I guess. Should I take that one, Sierra?
I can answer that one as far as the schedule goes. So it will be full-time. We break you up usually into two cohorts, one being run more on East Coast time and the other being more run on Pacific time. So you will have the option, if one works better or worse, we can put you in one of those groups.
Is there any limit of attempts to take the coding challenge for applying the fellowship? If one does not qualify for a current cohort, can you apply again for the next cohort? 100%. We certainly encourage you to do that. The more you do these, the better you'll get at them. If you're not successful the first time already, hopefully you learn a bit on the way, so the next time you apply, you know what to expect. But you certainly can apply again. Yes. Can you have a slider and a checkbox to select multiple categorical options to filter them together? Yes. And you can have a drop-down menu where you can also mark multiple or just a single one. You can have a checkbox where if you say selection single or selection multi. You can also have dragging, like in an Altair plot, you can drag with your mouse and select certain regions. So there's many different selector tools. Yeah, you can do all of that.
We had one more question pop up in the chat that says, are there any plots to visualize 3D surfaces for gradient descent algorithms?
I would say that for plotting 3D plots, essentially, many different libraries will have that capability. If you will, even just Matplotlib can do 3D plots that you can then rotate. It just looks a bit clunky like that. So I would say, yes, many. Now, which you would choose to kind of make a 3D plot that potentially you can also drag around nicely. The more sophisticated the library is with its interactivity, I would say, like Altair or many others, the nicer. But the answer to that would be many. Yeah.
Well, I want to thank everyone for attending today, and thank you so much, Ana, for your very detailed presentation. I know there's so many questions, so if we didn't get to your question today, if you'd like to ask another one, you're welcome to email us at our admissions inbox. We'd be happy to assist you there. And I saw another question about if this session is recorded. It is recorded. It will be sent out to all registered attendees. It typically takes anywhere from 48 to 72 hours to process, but it is also available on our YouTube channel as well. If you want to get a head start and just rewatch it right away, it will be available there for you. And just keep in mind of those dates to apply and submit your application. We've posted links in the chat to our application page. We have our email in there as well, and links to our scholarship and financing pages. So get a head start on applying for scholarships as well as the program. And again, if you have any questions and would like to be connected with an enrollment counselor, please reach out to us. But again, we thank you all for attending today and hope you have a great rest of your day. Bye, everyone.
Thank you, everybody. Bye.